It's a question we've been asking ourselves forever, from ancient poets to modern-day scientists. It's something every single one of us does every night. But why? In this explainer, we're going to try and unravel one of biology's biggest, most profound mysteries. Why in the world do we sleep? I mean, really think about it, especially from an evolutionary point of view. It makes zero sense. We spend roughly a third of our entire lives totally out of it, unconscious, unable to find food or, defend ourselves from whatever's lurking in the dark. So what could possibly be so important that it's worth that massive risk? So to kick things off, we need to get one thing straight. This isn't just about feeling a little groggy. The stakes here are as high as they get. We're literally talking life and death. And what's wild is we've actually known this for a long time. Way back in 1894, Dr. Marie de Manesine, who was one of Russia's very first female physicians, she discovered something that was just shocking. She was the first person to figure out that sleep isn't some kind of luxury. It's a biological necessity, maybe even more critical than food. And her experiments laid it all out there, crystal clear. She found that puppies deprived of food could actually go for more than 3 weeks and still bounce back. But the puppies that were deprived of sleep, they were, in her own words, irreparably lost in less than a week. They suffered horrible brain damage. The takeaway was just undeniable. Whatever it is that sleep does, it's completely non-negotiable for staying alive. And look, this isn't just about one person feeling tired. The collective price we pay for not getting enough sleep is just staggering. We're talking lower productivity, higher health risks. It all adds up to hundreds of billions of dollars in economic losses every single year. So clearly, something incredibly important must be happening when we're checked out. Okay, so we've established that sleep is absolutely essential. And that fact right there is what makes this whole thing so mysterious. Because when scientists really tried to dig in and explain why it's so vital, they ran into a huge problem. This life-sustaining process seems to break a fundamental rule of nature. See, in pretty much all of biology, there's this universal rule called allometric scaling. It's actually pretty simple. The bigger the animal, the slower its pace of life. Things like heartbeats, how fast they grow, even how long they live, it all slows down as the animal gets bigger. But sleep, it does the complete opposite. An elephant, which is thousands of times heavier than a squirrel, actually sleeps 4 to 5 times less. While basically every other biological clock slows down with size, the sleep clock seems to hit fast forward. It's the one exception to this massive rule. How weird is that? So this was the puzzle that totally stumped scientists for decades. Why is sleep the one rebel in the biological family? Why does this one single function defy one of the most reliable patterns in all of nature? Well, it turns out the answer was hiding in plain sight. All right, so the first big breakthrough came when researchers stopped looking at the whole body and instead focused on our most complicated and, well, our most energy-hungry organ. So, your brain, it's actually surprisingly small, right? When you think about it, it only makes up about 2% of your total body mass, just a tiny little piece of the whole system. But, and this is a huge but, that tiny 2% organ is a total energy hog. It burns through an incredible 20% of your body's entire energy supply. That makes it a very, very expensive piece of hardware to keep running. And all that work, every single thought, every signal, it creates waste products and damage, kind of like an engine that's always running hot. So a huge reason we sleep is to take the brain offline. Think of it like this. You can't repair a busy highway during a rush hour, right? You've got to shut things down at night to fix the potholes. Same idea. And bam, this perfectly solves the paradox for adult animals. As brains get bigger, they actually get more efficient. An elephant's brain is enormous, but each little piece of it works more efficiently and creates less damage than a tiny piece of a mouse's brain. So, less damage means less time needed for nightly repairs. Mystery solved, or so everyone thought. So right when scientists thought they had it all figured out with this beautiful, elegant theory, they decided to test it on a different scale. Not between a mouse and an elephant, but within a single species, from a baby to an adult. And that's when the whole thing just fell apart. I mean, the logic seems perfect, doesn't it? A tiny human baby should act like a small animal, and a big adult should act like a big animal. So, of course, a baby needs to sleep more than an adult. And yeah, that part's true. But when you look at the numbers, that's where the theory completely breaks down. Just look at these numbers. A tiny little newborn sleeps something like 16 hours a day. That is 4 to 5 times more than a multi-ton elephant. According to that brain repair theory, this should be totally impossible. The math just doesn't add up. Not even close. So, what this meant was that the theory wasn't exactly wrong, but it was definitely missing a huge piece of the puzzle. The way a growing child sleeps can't just be a smaller version of adult sleep. It has to be for a completely different reason. It was back to the drawing board. And that's what led to the final and honestly mind-blowing revelation. The reason the theory didn't work is because we've all been thinking about sleep in the wrong way. It isn't just one thing, it's two. What researchers found was this incredibly sharp cutoff point, a sudden transition that happens right around 2.5 years of age. Before that point, sleep's main job isn't repair at all. It's construction. It is actively building and reorganizing the brain. And after that point, its main job switches over to maintenance. A really great way to picture this is the water versus ice analogy. Before age 2.5, the brain is like water. It's fluid, it's plastic, and it's rapidly making all these new connections that let us learn at an incredible rate. But after that transition, it becomes more like ice. It gets stable, more crystalline, and the focus shifts to preserving the structures that have already been built. So that's really the heart of it. The reason a baby sleeps so much isn't because its brain is making a huge mess that needs tons of repairs. It's because its brain is doing the absolutely massive job of wiring itself from the ground up. And that process is fundamentally different from the maintenance work an adult brain does. They just look the same on the outside. And you have to understand, the implications here are just massive. It means that sleep in those first few years of life isn't just about rest. It is the absolute critical time for actually building the brain. And it suggests that this foundational work, well, it can't be made up for later on. This idea completely changes how we should think about childhood development. And this leaves us with one final kind of wild thought. This water phase of the brain is our absolute peak for learning and for changing. Now that we know it's a distinct biological state tied directly to sleep, it makes you wonder, could we ever find a way to extend it